I'm going to show you how VMware solutions address some common security use cases around ransomware, API security, and misconfigurations. Let's start with ransomware. In this use case, we'll focus on VMware's NSX network detection and response and Carbon Black Cloud. NSX NDR can detect and prevent advanced threat actors from taking hold and ransoming your modern applications, VDIs, and workloads. In order to gain initial access to an environment, attackers often target your employees. In this case, we will see that through phishing, a backdoor is installed on the employee's VDI desktop, giving the attacker a foothold. Attackers then establish communications via command and control, move laterally to gain access to, for instance, a database, which holds the monetizable data. And we've seen with a lot of recent ransomware incidences, attackers exfiltrate data out of the organization and then drop and execute ransomware in the environment, in this case on the database server, which causes critical data to become encrypted, after which they demand payout. With NSX NDR, we can correlate individual events from the NSX Sandbox, a malware prevention solution, network traffic analysis, and intrusion detection and prevention solutions into a campaign which provides security operators the full story behind an intrusion and maps every event to the MITRE ATT&CK framework. The security campaigns view provides a high-level overview of correlated tactics and techniques we observed within the environment. In this campaign view, we see further evidence of 4 threats targeting 2 hosts. The attack stages align to the MITRE ATT&CK framework, and we see evidence of delivery of some malicious artifacts, communications via command and control, and lateral movement and exfiltration. Now let's have a look at the blueprint of the intrusion campaign, and let me rearrange this visualization a bit to match our network topology. Here we have our attacker on the outside, and here we have our VDI desktop and our DB server, so let me put it over here on the left. The first thing that we saw was the VDI desktop download a malicious file that was hosted by the attacker that was detected by our malware detection and prevention capabilities on the gateway and distributed firewall. Then our IDS at both the distributed and gateway firewall detected the Darkside command and control session with the attacker. Our network traffic analysis then detected the network traffic anomaly, in which the attacker used the Eternal Blue exploit, a vulnerability in SMB version 1 protocol that essentially allows threat actors to move ransomware laterally through the network like we see here. And then we see exfiltration. The timeline view here helps connect the dots along the MITRE ATT&CK framework. First, the NSX Sandbox detected a malicious file download from an external source via phishing, and it ended up being the Darkside ransomware. The NSX Sandbox does have preventative measures here and can stop this from happening. Next, we see the establishment of command and control via the IDS. Again, preventative measures can stop this communication. Our network traffic analysis then detects anomalous lateral movement via Eternal Blue, where it laterally delivered the Darkside ransomware to the database server. From there, Darkside command and control communications were established, followed by exfiltration of data via an encrypted command and control channel over the DNS protocol, which is an effective tunnel out of most networks. This gives us a complete network overview of the campaign as we have correlated and connected the dots of the threat activities we observed through the network. All of this without the needing to deploy any sensors in the network, without needing any hairpinning, without spans or tap, and regardless of network connectivity. So with this, we have completed our analysis and learned that this was not just a case of ransomware being executed on a database server, but we've learned that the attackers gained initial access via VDI desktop, were able to move laterally due to lack of segmentation, and were able to ransom and exfiltrate data out of the database. And not only do we have access to every packet, but we also have access to every process within VMware Carbon Black Cloud with the detection of the Darkside ransomware on the VDI and database server. Let's start with Carbon Black Cloud's alert page, where security admins can filter out vulnerabilities, priorities based on criticalities, from low to critical. This gives them a realistic, prioritized method of dealing with risks and threats in the environment. Here we can see 2 critical alerts on the same Darkside ransomware attack. The first alert detects the Darkside ransomware exists in our environment and identifies this known variant. The second notification has higher severity as Carbon Black Behavior Engine also recognizes ransomware-like behavior from this VDI. As we can see, this attack has modified the OS registry to delete shadow copies. This will prevent admins to restore the host. Let's take some actions against this ransomware attack. With a click of a button, we can delete this application from this host or through the environment. We can also put this host under quarantine. Next, we need to know the extent of this attack. We can see the AI-centric process tree depicting what this Darkside ransomware has done within our environment. We have identified the location from where the script was executed and what files were encrypted. Let's shift gears and talk about API security. It's important because APIs have become ubiquitous and part of the application's lifecycle management. APIs are the new attack surface, and for good reason. Most web traffic is actually API traffic. Let's touch on new applications frameworks. We increasingly see customers adopting applications based on Kubernetes and microservices. These applications are developed to be highly modular and scalable and are inherently multi-cloud. These applications can be accessed by any user from anywhere. So, it is important to have a consistent security operational model. VMware Tanzu Service Mesh provides policy control and visibility for all communications among applications, end users, services, and APIs. A key feature that sets the VMware solution apart from other service mesh offerings is the concept of global namespace. The GNS defines the application boundary and provides seamless connectivity, security, visibility, and policy controls expanding to any Kubernetes cluster running on any cloud. Within a global namespace, the distributed services that make an application are auto-discovered. In this example, we see the Acme shopping app with a front-end UI, a product catalog, a cart, and a payment system deployed over a multi-cloud environment. All communications between the services are controlled to regulate access and segment the application. All the services APIs, including the API parameters and the API schema, are automatically discovered. Also, all the personal, identifiable information exchanged by the APIs are monitored and tracked to verify and control access to sensitive data. Let's access our virtual store through the front-end UI and shop for a product. With Tanzu Service Mesh, we track a complete transaction, from when an application end user makes a request, and as that request follows through the service mesh, including services, APIs, and data. If an incursion is attempted, it is identified, access to sensitive data is tracked, and the attack is stopped with the adoption of the right prevention policies. Customers can prevent and deny any malicious request that is found to contain attacks and or ties to access sensitive information, and deny any malformed request that does not have a valid API schema. Finally, let's cover how you can manage security and compliance risk due to misconfigurations in a multi-cloud environment. For this, we offer a SaaS solution called Cloud Health Secure State. With Secure State, you can quickly manage your security posture by detecting and fixing misconfigurations, prioritize threat alerts from cloud-native service based on risk and overall security posture, and shift left by testing configuration settings within CI/CD pipelines and building guardrails to mitigate risk. The best practices built into Secure State help cloud admins create a security compliance program. This includes out-of-the-box Kubernetes security best practices like CIS benchmarks and compliance standards such as NIST, GDPR, HIPAA, and many others. An intelligent risk scoring algorithm makes it easy to identify vulnerabilities. Here's an example of a violation. The EKS service account within the cluster allows access to a privileged IAM role. Unless corrected, anybody with access to resources in the cluster can have administrative privileges to the full cloud account. Let's zoom in into one EKS cluster. We can detect and get insights into violations listed by rules or by objects. These views help investigate findings like an EKS node group within an IAM rule that violated EC2 privileges. We can drill down to learn more about a finding and then decide to remediate or suppress it. We also have deep visibility into misconfiguration risks across multiple services and resource types, including managed and self-managed Kubernetes clusters in a public cloud or data center. A cloud security admin can resolve violations and use automation to improve the security and compliance posture and to build guardrails to prevent mistakes. Each violation is assigned a risk score based on the potential blast radius. You can proactively identify risk, such as Kubernetes service account, with cloud accounts administrative privileges to prevent cloud hijacking. Thanks for watching our demos on how VMware delivers on the promise for a secure multi-cloud solution.